topic is derivation for magnetic vector potential A equal to integral of mu naught IdL by 4 pi r. Now let us see the figure. There is a current conductor and consider a small element, differential element dl dash at x dash, y dash and z dash. To do this differential element dl dash, there will be a magnetic field strength at point P at x comma y comma z. So differential length dl dash is located at r dash distance from the origin, and point P is located at distance r from the origin. Now h at any point P x comma y comma z due to the differential and the dl dash at x dash y dash z dash is given by h equal to line integral of I dl dash cross r by 4 pi r square. So we know that what is the relationship between magnetic field flux density and magnetic field strength. So B is equal to mu naught H. So B is equal to mu naught by 4 pi line integral ideal dash cross r by r cube. So what is r? R is the distance vector r minus r dash, that is second point minus first point. So x2 minus x1 ax, y2 minus y1 ay, z minus z2 minus z1 az. So second point is x comma y comma z. First point is x dash y dash z dash. So x minus x dash ax, y minus y dash ay, z minus z dash az. Now magnitude is nothing but x difference square, y difference square and z difference square all to the power of 1 by 2. Now we want to differentiate, we want to calculate del of 1 by r. So del of 1 by r means, so dou by dou x of 1 by r ax, dou by dou y of 1 by r ay, dou by dou x, dou by dou z of 1 by r az. So this is differentiation, partial differentiation of 1 by r with respect to x, with respect to y, with respect to z. Now, so we are differentiating 1 by r with respect to dx. Now let us see differentiation r 1 by r. So x to the power x dash whole square, y minus y dash whole square, z minus z dash whole square whole to the power minus 1 by 2. Because it is 1 by r, it becomes minus 1 by 2. Now differentiation of this term, it is just like x to the power of n, where n is equal to minus of. Okay, so what is the formula? X to the power of n differentiation n into x to the power of n minus 1. So n is minus 1 by 2 into x to the power. So whole term is treated as x and whole to the power of n minus 1. N is minus 1 minus 1 minus of minus 1. So the power becomes minus 3 by 2. After differentiating this one, and you have to differentiate inside. So y minus y dash whole square, z minus z dash whole square, differentiation with respect to x, these terms becomes 0, and differentiation of this term, what happens, it is also look like x to the power of n. Okay, so here n is equal to 2. So n into x to the power of n minus 1. N is equal to 2 minus 1. So 2 into x minus x dash, that's all. Okay, so what we are getting is all to the power of minus 3 by 2. All to the power of minus 3 by 2. Now let us see. Whole term this written can be written as whole to the power of 1 by 2 and again whole to the power of minus 3 into 2 into x minus x dash to the order, right? Okay, now this term appears to be nothing but r magnitude. So minus half into r to the power of minus 3 into 2 into x minus x dash. 2 is cancelled. What you are getting? Minus x minus x dash by r cube. So this is differentiation of 1 by r with respect to x, right? And dou by dou y of 1 by r is nothing but differentiation with respect to y. We will get minus y dash by r cube. Differentiation of 1 by r with respect to z, you will get z minus z dash by r cube. Okay, so gradient of 1 by r becomes differentiation with respect to x, differentiation with respect to y, differentiation of with respect to z. So that is x minus x dash by r cube, here y minus y dash by r cube, z minus z dash by r cube. So everything, every differentiation has minus term, minus, minus, minus. Take the minus common. Now it will become x minus x dash ax, y minus y dash a, y dash ay, z minus z dash az by r cube. Okay, so del of 1 by r equal to the whole term is nothing but r vector. So minus r vector by magnitude r cube. So r vector by r cube is equal to minus gradient of 1 by r. Okay, so we know that b is equal to mu naught by 4 pi, the 4 is missing. B is equal to mu naught by 4 pi, a line integral ideal cross r by r cube. In the place of r by r cube, substitute minus gradient of 1 by r. Here we have same thing is written here. So the place of r by r cube, substitute minus gradient of 1 by r. Okay, this minus 1 is taken outside the integral. So b is equal to minus mu naught by 4 pi, line integral ideal dash into del of 1 by r. So there is a vector identity del of del cross small f and capital F is equal to small f del cross capital F plus del small f cross capital F. Okay, here small f is the scalar, capital F is the vector. So let us assume small f is equal to 1 by r, capital F is equal to dl dash. And substitute this into this equation. Del small f means 1 by r, capital F means dl dash. Okay, small f means 1 by r. So del cross f means del cross f means dl dash plus small del f del small f means 1 by r cross, here it is cross f capital F, so cross dl dash, right? So now we want dl dash cross del of 1 by r. Okay, it is just like a cross b. You have to write it b cross a. It will become minus a cross b is equal to b minus b cross a. Okay, whole thing is written like this. Okay, so this part is moved to left side. dl dash dl dash cross del of 1 by r equal to first term as it is and this RHS LHS is moved to right side. It will become minus del cross of 1 by r dl dash, where on dl dash, right? Now, okay, now let us see first term. So gradient means what happened? Gradient is differentiation with respect to x, and dl dash means it is a function of x dash y dash z dash. So gradient of del dash means differentiation of x dash y dash with respect to x, y, z. So dl dash becomes constant. So differentiation of constant is nothing but 0. The first term becomes 0. First term becomes 0. Okay, first term becomes 0. Now what happens is, then dl dash of del of gradient of 1 by r becomes minus gradient of 1 by r dl dash. Right? So in the place of dl dash cross gradient of 1 by r, you know the mu naught minus mu naught 4 pi line integral ideal dash cross del of 1 by r. In this place, you have to substitute this minus gradient of 1 by r dl dash and substitute that one. So minus gradient del cross dl dash by r. So b is equal to minus mu naught by 4 pi line integral ideal dash cross del of 1 by r. That is equal to what we got here, that is minus del cross 1 by r dl dash. So substitute, you have to replace this term by minus grade del of del cross dl dash by r. Okay, so take this minus outside, it will become plus, and take this del cross outside the integral and del cross and move the mu naught 4 pi into the integral. Now it will become line integral of mu naught ideal dash by 4 pi r. 4 pi r. Yeah. What is that? We know that b equal to del cross a. Compare this with this one. B equal to del cross a. Okay, this second term, this term is nothing but magnetic vector potential, that is a equal to line integral mu naught ideal dash by 4 pi r. So this is what we derived. Okay, so in the vector identity, after simplification, we got what we are getting here. What we are getting is dl dash cross del of 1 by r equal to minus gradient cross 1 by r dl dash. This term is substituted here. After that, del is moved to outside, and for a mu naught by 4 pi is moved inside the integral, right? So this part is nothing but v is equal to del cross mu naught by mu naught into ideal dash by 4 pi r. This is nothing but magnetic vector potential. This is what we want. So this is what we want. Okay, this is the final derivation. Okay, so if we look at overall, okay, we got the equation b equal to, right, and gradient of 1 by r, what we are getting, gradient of 1 by r is equal to r by r cube. So r by r cube is nothing but minus gradient of 1 by r. So B contains r by r cube, that is replaced by minus gradient of 1 by r. Okay, minus gradient of 1 by r, that is substituted. Okay, so by using, okay, so after substituting that one, we will get B equal to minus mu naught by 4 pi ideal dash cross del of 1 by r. Okay, so by using this vector identity, we got dl dash del dl dash cross del of 1 by r equal to minus del of 1 by r dl dash. Okay, so dl dash cross del of 1 by r is replaced by this term. So that term is substituted here. This term contains minus gradient cross. So minus gradient cross is taken outside the integral, and mu naught by 4 pi is moved inside the integral. We are getting mu naught I by dl dash by 4 pi r. 4 pi r. So this is the B is equal to del cross A. Okay, so B is equal to del cross A. So this term is nothing but potential A, magnetic vector potential A. So A is equal to line integral of mu naught I dl dash 4 pi r. So this is what derived.